My name is David, and I'm here to talk to you about cloud computing. Cloud computing is a big topic, and we've been hearing a lot about it lately. In fact, I've noticed that the marketing people have started to hijack the word cloud computing, and they've started to put their own spin on it, which makes it a little bit harder to understand what people are talking about when they say cloud computing. So I want to begin with my definition of cloud computing. Cloud computing is when you have some third party host some or all of your data or your application in a highly scalable, highly reliable way. Now that's a very broad definition, and that is so by design because there are many services that are available in a cloud computing platform. Because there are so many, it is useful to group those services into these three broad categories. Infrastructure as a service, which we sometimes refer to as IaaS. Platform as a service, which we sometimes call PaaS. And software as a service, sometimes known as SaaS. And these groups of services, they help to organize your head around what the cloud services are. It's not correct to say that every cloud service falls neatly into one of these buckets, but they are a helpful organizational tool. Now, before we start talking about that, you need to understand where the cloud came from. And the cloud is enabled by something called virtualization. Virtualization has been around for decades. It is not new. People have been using virtualization to do more efficient on-premises computing for a long time. Virtualization refers to the process of taking a physical machine, its size, its hardware, its operating system, its data, its state, its software installed, and turning all of that into a single file. And then we can use tools like Microsoft Hypervisor, sometimes known as Hyper-V, to access that file and open it up and treat it as if it were a physical machine. And doing so gives us some advantages. For example, we could take multiple virtual machines and store them on a single physical machine, and sometimes this allows us to take advantage of more efficient use of hardware. Also, these virtual machines tend to be a lot more portable than a physical machine, so you can, for example, make copies of them if you want to run things in parallel. And then you can move them to another physical machine. That might be useful if you want to have some fault tolerance, if you want to run things in parallel on multiple machines, or if you wanted to, if hardware failed, then moving it over somewhere else might make a difference. Or maybe you want to move it to a bigger machine. There's a lot of flexibility involved in virtualizing your servers that wasn't available if everything was physical. It's a lot easier to move these files around than it is to recreate physical hardware. And people have been doing this. They've been virtualizing servers. Companies have been doing this for a long time, even when they hosted their own data center on premises. This is the traditional way that customers would host data and applications. They would buy a server, they would install an operating system on it, they'd install software on top of this, install their custom code on top of that, add some data, etc. Configure it the way they wanted to. And then maybe they would virtualize it. Maybe they'd build another server and another server. They had a whole data center. The issue with this is that this is costly. It's costly in terms of buying all this hardware, but also in terms of maintaining it. Now, because I own this hardware and I own this data center, I have to make sure that it's secure. I have to put it in a room with some security around it so nobody can break in. I have to make sure it's temperature controlled and the air is filtered because computer hardware tends to be very sensitive to that sort of thing. I have to hire somebody to patch the operating system and to monitor it and have all this stuff going on around my physical machines that are probably not part of my core business. My core business is analyzing data or selling marketing information or selling washing machines or life insurance or whatever it is. My core business is probably not maintaining this data center. I did that because that was necessary in order for me to run the software that is required by my company. But along came the cloud, and the very first services offered in cloud computing were infrastructure as a service. And this was simply taking virtual machines, and rather than having companies hosting them themselves on premises, having those virtual machines hosted in the cloud. So now the company, I don't have to worry about buying the hardware and maintaining the hardware and keeping it secure and keeping it in a room that's controlled in terms of temperature and air quality and so on. I don't have to worry about patching the operating system and replacing pieces of hardware that fail and making sure there's extra electricity going there. All of that's abstracted away from me. The cloud computer takes care of that. I'm just renting their physical hardware and I'm storing my virtual machines on that. And I can focus on managing that virtual machine. Now I still have to patch the virtual machine's operating system and any software built on top of that. I have to manage all that. So it's not totally abstracted away from me, but some of it is. If I want more abstracted away from me, this takes us to the next step, which is Platform as a Service, or PaaS. And in this case, not only is the hardware, the physical hardware, abstracted away from me, the customer, but so is the virtual machine itself. So I can just focus on the services that I'm consuming. If I want, for example, to create a database, I simply connect to my cloud provider and I say, I would like a database, I would like to be this size, I want it to be underlying a relational database built on SQL Server, call it this, and here's my admin account. I don't have to worry about what the operating system underneath and patching that. I don't have to install SQL Server. I don't have to hire a DBA to manage the clusters. All of that's taken care of for me. I can just simply start creating tables and views and stored procedures and connecting to them with my application through connection strings and so on. Same thing with web applications. If I want to build websites or web services, I can just simply create that. I don't have to worry about IIS or Apache or whatever the web server underneath that is. That's the cloud provider's problem. I just want to worry about deploying my code to a web server. And there are many, many services. There's things to manage big data and to do machine learning and deep learning. There's cognitive services for doing image analysis and text analysis, all sorts of things that are abstracted away that you don't have to worry about the server underneath. The next step is software as a service. And software as a service actually abstracts away even more. With software as a service, you don't really have to do anything as the customer. It's all taken care of by the cloud provider. These are things like Gmail and Outlook.com and Office 365, Salesforce.com, hosted CRM. All these things, I just connect to them, usually through a website, and just start using them. One day I'll log into my browser-based email, and there will be a new feature. I didn't have to do anything. It just showed up there, and I can just start using it. So everything's abstracted away from you. Now, as you look at this, I think it should be obvious that as I move to the right on this diagram, that I have less work to do. I can, for example, just connect to a web browser-based email, and everything just works, but I have less control. Somebody else is taking care of all of the applications for me. As I move to the left, I have more control. If I do everything on premise, for example, I can decide what brand of network card to insert into each computer. But I also have a lot more work to do. So you have to decide this trade-off, how much work versus how much control. And I would suggest that you should start on the right edge of this diagram when you're looking at a solution. If I want to build something and I'm looking for a component that does X, Y, and Z, and there is a service out there that already does X, Y, and Z for me, it's probably more cost effective for me just to use that service than to try and build my own. But maybe it doesn't do X, Y, and Z. Maybe it only does X and I need to create Y and Z. Well, Y and Z, there may be PaaS offerings that I can connect together and aggregate and build some code around and call these APIs and make those work and build something. But I may run into a limitation there. It's possible that for my web application, for example, maybe I have to have something else installed on the same server as that, or something updated in the registry to have more control over that, in which case IaaS might be an example. I can control my own virtual machine. So generally speaking, you want to start on the right side looking for solutions, and only when you hit a limitation would you go to the left, and that tends to be more cost effective. Reliability. I did mention that in order for a cloud solution, for something to be called cloud computing, it has to be highly scalable and highly reliable. Reliability is the simple one. The way that it's handled in Azure and some other cloud providers is that multiple copies of your data are written and they are kept in sync. Only one of those copies is live, so your customers will connect to one copy of that, and as they update it, it'll automatically keep in sync other copies of this. And those are really there just for redundancy, for fault tolerance. So that if for some reason your live copy of your data goes down, either because of a hardware failure or because you need to upgrade the operating system of the hardware underneath or whatever, then you can fail over, make another copy of the data, the live version, point all your users to that, and create an extra backup copy. So you always have 3 copies of this. And you can configure this. Some servers actually let you have even more than 3 copies of this. Sometimes you can have control over where they're going to be. And this is how reliability is managed in Azure with lots of monitoring. You don't have to do this yourself. It's all taken care of by the Azure Service Fabric, which monitors when things are healthy and when things go wrong. And if something goes wrong, then it will automatically fail over to another copy of your data or your application. Now, highly scalable is related to elasticity. And elasticity refers to the ability of your application to respond to changes in demand. Very few applications have a constant demand over time. Generally, there's some volatility in that. So here's a diagram of some changes in demand. Don't worry about the units here, but you can see that in October and November, it looks like demand got really, really high, and it's really, really low in February. In applications, this is pretty common in applications. So for example, at one time, I was a consultant and I worked for a large electronic retailer, and they did almost all of their business. Like 80% of the revenue was generated between Thanksgiving and New Year's. That's when people buy it. It's the Christmas shopping season. And they hosted their own data center back then. And what they had to do is they had to deploy enough hardware to meet their peak demand. Or I should say they chose to do that. And there's a problem with this. They had about 5 or 6 weeks where that capacity was being fully utilized, but they had a huge chunk of the year where it was being underutilized. It was barely being utilized at all. There was just waste. They still had to have climate-controlled rooms, and they had to buy the hardware and maintain it, and hire somebody to monitor it, and patch the operating system, and replace the hard drives that went bad, and so on. So they were spending this money for 11.5 months or 10.5 months just to get that one brief money-making season. Of course, they could have done something like this. Let's just average it all out, but this is imperfect as well. I mean, first of all, there's still waste. They wouldn't have hit it exactly, but more importantly, the reason they didn't opt to do this is all this lost opportunity. They really had to make money during that holiday season. And generally speaking, the more volatility there is in this demand, the more expensive it is to maintain your own servers on premises. Because sometimes this graph doesn't look like this. Maybe it's not monthly this thing varies. Maybe it's daily or hourly. You know, this volatility can be extreme. In fact, here's actually what they would like to do, something like this. In this case, deploy hardware whenever demand goes up, buy some new servers, and deploy them. When it goes down, sell those servers on eBay and then buy them back later on and redeploy them. Only deploy the hardware that you need when you need it. Now, that's really not practical if you're buying your own servers. In large organizations, it could take weeks or even months to deploy a new server. So it's not practical to say, every hour we're going to monitor this and go out and buy and deploy hardware. But with cloud computing, it is. It's easy. You can simply configure your applications, just configure your service to say, all right, I was using 2 instances of this application, but demand is going up right now, and now I want to use 20 instances of that application. And the demand goes back down, okay, I'm back down to 2 instances. You can decide how much you want to deploy. And there's a cost to it. Of course, you're renting that, so 20 instances cost twice as much, or 10 times as much as 2 instances, so you only want to pay for that while you're actually using them, while you're making money with them. But that's the ideal situation. You can do that through configuration. You can do that through the portal. You can do that through setting some thresholds, saying whenever something like CPU usage gets above a certain percentage of maximum, automatically add an instance of a service, and when it falls below a level, automatically remove an instance, and things like that. There's a lot of flexibility in cloud computing, and it's really useful for things like this electronic retailer, or maybe it's not as predictable as that. Maybe it's sort of ad hoc, like concert tickets are going on sale, and I happen to know that tomorrow at 3 o'clock, Katy Perry concert tickets are going on sale, and so I want to beef up my services. I want to run 10 times as many instances because I know Katie's fans are going to flock to the server to buy up all our concert tickets, and my server is going to get hammered for the next hour until they're sold out, and a few minutes after that, people will stop coming when they realize it's sold out, and my servers will be pretty much idle for the next couple of weeks until U2 tickets go on sale. It may even be unpredictable. For example, what happens if I have a web application that has moderate popularity until Oprah Winfrey mentions it on her show, and all of her minions flock to my site, and all at once, and suddenly demand goes up by an order of magnitude within an hour. Well, if I don't have some sort of elasticity, some way of handling that, then my service just won't be able to handle that capacity, and I'll miss out on that opportunity. Another example is some things like data science, like machine learning or deep learning or predictive analysis or big data analysis. Some of these things are notorious for taking a lot of compute power for a really short period of time, and then they sit idle for a while. So they're big compute intensive operations that make sense for a short period of time, and then we stop using them for a while until the next problem we want to solve comes along. And this is probably the main reason why data science has just exploded as a field in the last couple of years, is because the cloud has empowered us to throw a whole lot of compute power at this. We don't have to own these huge data centers in order to solve really hard predictive analysis problems. All right, everything I've talked about so far is pretty much true of any cloud provider. Now I want to talk specifically about Microsoft Azure. First thing everybody asks about, how much does it cost? And I never memorize this stuff. I just point people to go to azure.com and click the pricing link at the top, or you can go directly to that, azure.microsoft.com/pricing will get you there, and that will list all of the prices for all the services. So all these dozens of services, each one has a different pricing model. Typically it's quoted dollars per hour, although it's actually charged by the minute. So in other words, if I only use a service for 10 minutes, then I'll only be charged for a sixth of the hour. And there are factors like every service type has its own scale of pricing, and generally for almost every service you get to choose what size of machine you're going to run this on. If you're going to run it on a very large, beefy machine with lots of memory and lots of cores and lots of processors, then you will pay more than if you want to run on a small machine with just one core and just a bit of memory. So that's quoted in this pricing page. And then, of course, the number of instances. Most of the services in Azure will run in parallel, and if you want to have 10 instances of a service running, well, that costs twice as much as having 5 instances. It's a linear service, although hopefully it'll run about twice as fast. It's not quite linear in terms of its performance because there's some overhead, but it will run a lot faster if you can take advantage of parallel processing, which many tools can. And we talk about the services. Here's a list of them as of today, as of late May 2018. This is, you can go and look at this website, this URL at the bottom left. It's anytime, and this list gets longer and longer. The Azure team is constantly adding new services and new features to existing services. We're not going to cover a lot of them here. Maybe in future videos we will. And here are the regions that are available, and a few that are actually announced soon. As of May 2018, there are 50 regions. Azure is available in 140 countries. You can see this at any time by going to the URL at the bottom left there, and it'll show this list here. And this is a big advantage that Azure has. There are really only a few players in the cloud computing market that can do this kind of scalability, this kind of worldwide delivery network. And this serves a couple of purposes. One is because there are so many regions, because every region has these large data centers, that's a huge amount of capacity. So the scalability is probably beyond what you will use. You can probably think of it as infinite scalability, if it's beyond anything that you would ever consume. Another good advantage of these regions is for latency. If your customers are in Southeast Asia, well, it makes sense to deploy your applications to Southeast Asia, so they don't have to go halfway around the world in order to access your application. They can just access it from a server that's close to where they are. Or if your applications are consuming databases or other services in a certain part of the world, then it makes sense to deploy your applications to that part of the world where the data is, so that latency is reduced. And also for fault tolerance. In some of the services, you actually have the ability to create multiple copies of your data in different regions. So you're protected against natural disasters and things like that. Sometimes things go wrong, and sometimes it's your fault, sometimes it's Microsoft's fault. And this page right here, the URL at the bottom left will show you the status of Azure at any given point in time. And what's nice about this is that when something goes wrong with your application, one question you may ask yourself is this something I did wrong, or is there a problem with Azure? And this will help to resolve that. So in the day I took this one, which I think was about a month ago, there weren't any problems, at least not in the Americas. But you can see that there are, for each one of these combination of services and region, it'll list whether there's it's up at good, meaning everything is running just fine, there are no problems, or warnings or errors. Errors, of course, are more. These are full or partial outages of these services. And then if a service is, if there was a problem and it has been resolved, you may see an information icon. Each one of these you can drill down into and see what exactly the problem is or was and when it's expected to be resolved. Any information we have should be posted quickly to this site. And finally, this is the portal. I'll show you an example of that in about 1 minute, but here I can see the services I've created. I can filter those services. I can create a new service. The way that I create new services is this big button at the top left. There's a green plus sign next to it, and on my portal it says create a resource. Sometimes it'll have the word new. I think those are the older versions of the portal that are being migrated to create a resource, but either one does the same thing. Click on it, it'll bring up a blade that asks you, what kind of service do I want to create, and once I select the service, then there'll be a dialog that will walk you through asking the questions that are pertinent to that service. Let me show you an example. Here's a quick demo. If I open up a browser and navigate to azure.com, that'll redirect me to the correct Azure page in my country. You can see that I can create a free account right here, but I already have an account, so I'm going to navigate to the portal. I'll sign in. It caches my password, so I don't have to type in that. And it takes me to the portal. And the portal has information about the health and some marketplace things and a link to help and support. It also has a list of some of my resources. If I want to see all my resources, I can list them down here. If I want to see them, just all the resource groups, I can go in here and open up one of these and see all of the resources in that resource group. And if I want to create a new resource, then this big green plus button in the top left is what I'll click. Here you see some categories here. I'm going to create a simple web app right here by selecting web and then web app. And because I've selected web app, then this dialog, which is called a blade, pops up and it prompts me for things that are relevant to a new web app. For example, the app name. I'll call this one GCast My Web App right here. This has to be a unique name because ultimately the URL of this web app is going to be https://dgtestmyweboapp.azurewebsites.net. Now later on I could point a DNS record to this to give it a custom domain, but that's the default name for it. Most of you only have one subscription, so just leave that alone. Resource groups are here. I'm going to call it GCast My Web App RG for resource group. Resource groups are just a way of grouping together lots of related resources. So for example, if I had a database and a web app that I always worked with them together, I could open up the resource group and they would both be in there. I can specify whether this should be in Windows or Linux, or I just want to deploy everything to a Docker container. And then I select the app service plan. The app service plan allows me to specify the location of my web app and the size of the instance on which it is running. So I'm going to create one I'll call it DG test my web app ASP for app service plan. I'll put it in the central US. I happen to live in Chicago, so that makes sense. And then my pricing tier standard is okay. But if I click on this, you'll get an idea that standard is just one core, 1.75 gigs of memory. And if I let it run all day, every day, it'll be about $74 a month. That's an estimate because it assumes 30-day months. But I'll leave that. That's fine. I can pay a lot more and get multiple cores, or I can pay less and get a cheaper instance. So I'll select that and click Apply right here, and then click OK to accept that those are my app service plan settings. And then I'll click Create, but first I'll pin it to the dashboard. What that will do is make it appear on my dashboard so that as soon as I log into the portal, I'll automatically be able to see it. Now you'll notice that right up here, this little bell shows that deployment is in progress. It's actually creating this thing. A web app doesn't take very long, maybe a minute or so. Some services might take up to half an hour to create and deploy, but this is not very long. And when it's done, I can click Go to Resource, and actually it opened up automatically. Here it is. And in here, you'll see, for example, there's a quick start down here. If I want to quickly write some code and deploy it, it can be PHP code, Java code, Python, Node.js. That's all supported here. In the overview, I actually have a link to the URL. And by default, even though this is a brand new one, it did create one empty page for me. Or not quite empty, one kind of default landing page right there. But you'll want to override that with your own custom code. There's things in here for how do you want to deploy. You can deploy from your source control. You can FTP. You've got a lot of options there. Do you want to set authentication, authorization on it? Do you want to add some monitoring to your application? Do you want to back up the code in your application? Set some SSL certificates? All sorts of things that are available in here to configure this web application. And that's typical. Just about any service you have, you answer a few questions, it'll be up and running pretty quickly, but you have the flexibility to overwrite and set these things. So this is just one example of how to create an Azure resource. In this video, I've shown you how to work with Microsoft Azure. I've shown some of the basics of cloud computing, and I've showed some of the basics of Microsoft Azure. I hope you've learned something. My name is David. Thank you for watching.